We're 8,000 person population, 9.5 square miles, but we've got almost 100% of our town is water, about 90% has sewer. We've got a big tertiary wastewater treatment plant. We've got 2 water treatment plants. So we had a lot of infrastructure in a small, manageable community. We first discovered the PFAS contamination in the fall of 2016. And at that point, we could keep the levels below 70 by the way we operated our system. So we basically shut off the well with the highest levels. I wanted to be proactive and have a plan for how are we going to deal with this.
This will be the first anion exchange permanent facility in Massachusetts. It's relatively new technology, so it's just sort of exciting and unique, especially in Ayer, where we have 2 different treatment plants with 2 different well systems where they have detected PFAS, and we have done testing to determine that actually 2 different treatment solutions are the right solution for each individual facility. I think the pace of the response, or the pace of the expected response, weighs pretty heavily on most of our water clients. So from the minute you get that first sample, and then you have to do a confirmatory sample, you're off to the races. There is no time to patch together a plan or figure out what you're doing. You kind of already need to be up to speed on what PFAS is and how it might impact your treatment plant.
At the point that we were at, most of the systems, the municipal water systems, were looking at GAC as a treatment process. I did a little research and said, boy, ion exchange looks like it's a pretty feasible alternative, and it's a lot more efficient in treatment because it's a smaller footprint.
At CDM Smith, we really pride ourselves in being able to perform a non-biased comparison of all of these different media products that are out there. We think it's really critical that we perform this independent comparison of all of these media products in the site-specific water under exactly the same water conditions and design parameters in a laboratory setting that is controlled and closely monitored with no to little chance of cross-contamination, which is a pretty significant issue in measuring PFAS. So first, we sampled a number of 30-gallon drums from the Ayer's actual water, and we shipped them to our research lab in Bellevue, Washington. If you look at the treatment process themselves, they are large pressure vessels. Some of the homes that have groundwater wells, you might have some of these smaller vessels in your basement to treat, hardness and make sure you don't have red water, except they're like much bigger. Inside, what you're gonna see is these tiny little bees. They almost look like fish eggs that come with your sushi, and these are made of special materials that could absorb PFAS onto the resin. And when I say absorb, like here's the resin, right? That's magnified by like probably 1 million times. And here's PFAS floating water, and it gets like absorbed to the resin, and that's how PFAS gets removed through anion exchange resin.
I think Mark is especially the reason why we looked so hard into anion exchange. He recognized all of the technical advantages of that, it being a smaller footprint and being a more efficient process. It's really rewarding working for somebody who just cares so much about what they're doing and has so much great input.